Okay, let's dive right into this. Welcome to today's explainer. We're looking at an absolutely foundational concept in software engineering, prescriptive process models. And specifically, we are zoning in on the granddaddy of them all, the waterfall model. If you've ever found yourself wondering how on earth complex software gets built systematically without just collapsing into total chaos, well, this is exactly where it all started. So, here's our roadmap for today. We've got the software process model, anatomy of the waterfall, building a library system, advantages and pitfalls, and finally, waterfall versus agile. Actually, having this clear, step-by-step plan perfectly mirrors the core sequential philosophy of the waterfall model itself. Let's get to it.
All right, Section 1, the software process model and the desperate need for structured development. To really appreciate the solution here, we first have to wrap our heads around the absolute chaos of unguided software creation.
Imagine trying to build a complex app with zero map or blueprint. It'd be a mess, right? That is exactly where a prescriptive process model comes in. It's essentially a strict framework. It provides absolute discipline by acting as your ultimate instruction manual. It tells developers exactly what to do, when to do it, and precisely how to do it. Without this kind of rigid discipline, delivering reliable software and keeping any kind of quality control is virtually impossible.
Moving on to Section 2, anatomy of the waterfall, where we'll focus on its famous sequential flow. Let's take a look at the oldest and arguably the most famous of these prescriptive models.
Proposed by Winston Royce, the waterfall is a classic linear sequential model. It breaks everything down into 6 distinct steps: requirements analysis, system design, implementation, testing, deployment, and finally, maintenance. Now, the defining rule here, the absolute golden rule, is gravity. Progress flows heavily downward, just like a waterfall. The output of one phase becomes the locked-in, non-negotiable input for the next. And here's the kicker. One phase must be 100% completely finished before the next one even begins. No jumping ahead.
Let's drill down into that very first phase and see how this all builds. Phase 1 is requirements analysis. This is all about getting in a room, conducting client meetings, and deeply understanding user needs to figure out what the customer actually wants. We capture all of this in a foundational document called the Software Requirement Specification, or the SRS. Listen, this document is the law. It dictates absolutely everything that happens downstream, so you have to know exactly what you want on day one.
Next up is system design. This is where we take that super strict SRS document and translate it into technical specs. We're creating the high-level and low-level architectural, database, and user interface blueprints. Think of it this way. If the previous step was deciding what to build, this phase is deciding exactly how it's going to be built technically.
Once those blueprints are totally finalized, we hit the implementation phase. This is where the rubber finally meets the road. Developers take those strict blueprints and start coding the actual modules, whether they're using Java, Python, C++, PHP, you name it. But that golden rule from earlier, it still applies. They are building exactly what was designed. No more, no less. No improvising here.
All right, after the code is actually written, we move right into testing and deployment. Now, testing is an incredibly critical step here. Through unit, integration, and system testing, the entire goal is to hunt down defects, verify those original requirements, and validate the software before it ever even reaches the user. Once every last bug is squashed and fixed, we deploy. The software is installed, users get trained, and it is officially out in the wild. But, the life cycle doesn't just stop at delivery. The final stop is the maintenance phase. Software requires ongoing corrective, adaptive, and perfective updates throughout its entire life. We're talking about fixing new, unforeseen bugs, rolling out security updates, or pushing adaptations as the tech environment changes. In fact, believe it or not, this phase is often the longest and literally the most expensive part of a software's entire existence.
So that transitions us perfectly to Section 3, building the library system. Abstract concepts are great and all, but let's anchor this timeline to a real-world example to see how it actually plays out.
Imagine mapping that abstract downward waterfall flow onto a strict 6-month timeline to build a library management system. Month 1 is purely gathering needs. Month 2 is designing the database. Month 3 is spent coding, and so on. You can really see how this rigid sequence plays out in reality, right? But here's the catch. If you are deep in month 3 coding, and suddenly the head librarian decides they absolutely need an integrated coffee shop checkout feature, well, you've got a major disaster on your hands. Why? Because month 1 is completely sealed off, no going back.
Which leads us nicely into Section 4, Advantages and Pitfalls. Let's evaluate Waterfall and really look at when this gravity-driven model works beautifully and when it can lead to a total disaster. Let's start with the good stuff, the advantages. The Waterfall model is just incredibly simple and easy to understand. Because of its highly structured nature, you get proper, thorough documentation at every single step. And that makes project management highly predictable. It is extremely suitable, ideal really, for small projects where the requirements are clearly defined and practically set in stone from day one.
But, as we hinted at, there are some fatal flaws. So, the crucial point here is recognizing these risks. First off, it is incredibly difficult to change requirements midstream. Plus, think about it. Testing happens dangerously late in the overall process. If you discover a fundamental design flaw at the very end during testing, it is massively, massively expensive to fix. Throw in a total lack of customer feedback during the actual build phase, and you are looking at a highly risky methodology for any large-scale or complex project.
All right, let's move to our final section, Waterfall versus Agile. Let's put this classic model up against a modern reality check. Directly contrasting Waterfall with Agile reveals a pretty massive shift in philosophy. It's like night and day. Waterfall is strictly sequential. Agile is iterative. In Waterfall, changes are difficult. In Agile, they're not just easy, they're expected. Waterfall involves very little customer feedback during the build, whereas Agile relies on it constantly. This huge leap from low to high flexibility is exactly why the software industry today so heavily favors Agile, especially for projects where requirements are practically guaranteed to shift around.
However, Waterfall definitely still holds a foundational place in software engineering, especially for highly structured, predictable systems where rigorous documentation is absolutely vital. So, I'm going to leave you with this final thought to apply to your own learning. With changing requirements constantly reshaping the tech landscape, is the Waterfall model the right methodology for your next software project? It's a question every single engineer has to answer. Thank you so much for joining me for this explainer, and keep learning.